Hello all. After having discussed some sequences like arithmetic progression, geometric progression, an infinite GP and a harmonic progression, I am going to teach you the last concluding portion of this chapter, some special sequences. Now, why are they special? It doesn't, why you call them because they don't fall under any of these categories. So, I will begin with some simple one. You may be able to put them into one of these categories by suitable whatever, we will do that. Okay. Now, the first of these two is, suppose you are asked to find the sum of these terms, these n terms. What you do is, this 9 you write as 10 minus 1, 99 is 100 minus 1, this is 1000 minus 1 and so on and n such terms. Okay. Now, in each of these brackets you have two terms. Suppose I club the first of them, what would I have? It is 10 plus 100 plus 1000 plus so on minus these n ones can be added up to get an n. Okay. So, look at the first bracket. Isn't this a GP in which the first term is 10 and the common ratio is also 10? So, what is its sum? It is 10 into 10 raised to n minus 1 by 10 minus 1, that is 9 minus n. This is your required sum to n terms. Okay. So, you should understand that this will help you only if you have 9s. So, what happens for some other sequence like this, for example, what happens if you have a term like this 7 plus 77 plus 777 and so on up to n terms. So, I told you this will hold only for 9s. So, introduce a 9 by dividing outside by 9. First of all, take a 7 out. So, you will have 1 plus 11 plus 111 plus so on. Okay. Now, with it you divide outside by 9 and multiply inside by 9. You have 7 by 9 into 9 plus 99 plus 999 plus so on up to n terms. Now, this is the bracket which we have already evaluated. So, this you can do like before 10 minus 1, 100 minus 1 and then you get this answer. What is it? It is 7 by 9 into 10 into 10 raised to n minus 1 by 9 minus n. This is the sum of this sequence now. Now, what happens if you have something like this? 5 plus 5.5 plus 5.55 plus etc. up to n terms. Okay, I told you that similarly 9 has to be introduced. So, what I do is take a 5 out and then multiply and divide by 9. So, I would have 9 plus 9.9 plus 9.99 plus so on. Yes. So, this 5 by 9, what is 9? 10 minus 1. This is 10 minus 0.1. This is 10 minus 0.01 and so on. Okay. So, this here in this bracket the first of these are the same. So, n such 10s can be added together to get 10n. So, this is 10n minus of, you have 1 plus 0.1 plus 0.01 plus so on and n such terms. So, what is it? It is 5 by 9 into 10n minus. Now, look within the brackets. Isn't that another GP with 1 as a common term and 0.1 as a common ratio? What is the sum to n terms of a sequence like that? It is A into 1 minus r raised to n divided by 1 minus r. This is your answer. This is one kind of special sequences. Now, another set of sequences whose formula you should memorize. You do not need the derivation, but you should understand sum of the first n natural numbers is n into n plus 1 by 2. Though you do not know the derivation, just remember that this is an AP with n terms. You would have this as the answer. Now, next is sum of the squares of the first n natural numbers is n into n plus 1 into 2n plus 1 divided by 6. Sum of the squares of the first n natural numbers. Now, sum of the cubes of the first n natural numbers is n into n plus 1 divided by 2, that is the square of this. So, let me tell you a simple way of doing one problem like based on this formula. What if you are asked to find the value of 10 squared plus 11 squared plus 12 squared plus etc. plus 50 squared? Okay, isn't this 1 squared plus 2 squared plus etc. plus 50 squared minus, isn't this 1 squared plus 2 squared plus etc. plus 9 squared? What is this bracket's sum of the squares of the first 50 natural numbers? N into n plus 1 into 2n plus 1 divided by 6. Minus, what about the second brackets? 9n into n plus 1 into 2n plus 1 divided by 6. That is your second brackets. Evaluate this. This is your required sum. Now, one more. Suppose you are asked to evaluate 1 into 2 into 3 plus 2 into 3 into 4 plus etc. n such terms. Write down its general term. What is the format that you see? Isn't it n into n plus 1 into n plus 2? Sorry, n plus 2, n plus 2. So, this is n squared plus 3n plus 2 into n. So, which is n cubed plus 3n squared plus 2n. This is the general term of this sequence. Now, you are asked to find its sum. What is its sum? Sum means sigma of n cubed plus 3 into n squared plus 2 into n. Now, let me just remind you of some properties of sigma. Okay? Sigma distributes over addition and subtraction, and constants can be taken outside the sigma. If I make use of properties of those properties, what would I have here? Isn't this sigma of n cubed plus 3 into sigma of n squared plus 2 into sigma of n? So, this is n into n plus 1 by 2 the whole squared plus 3 into n plus 1 into 2n plus 1 divided by 6 plus 2 into n plus 1 by 2. You can take common terms outside and put it in a better format if you want, but this is the sum to n terms of the sequence. Another one, 3 into 1 squared plus 5 into 2 squared plus 7 into 3 squared and so on, n such terms. Here again, what do you observe? It is the product of two terms, the second of which is easy to understand, it's just n squared. What about the first one? 3, 5, 7, all that, isn't that an AP? What is its general term? Isn't it A plus n minus 1 into D? So, isn't this 2n plus 1 into n squared is the general form of a term like that. So, what is it that you have? 2n cubed plus n squared, that is your general term. Now, the question is to find the sum to n terms. What is that? Sum to n terms will be sigma of 2n cubed plus n squared, which is 2 into sigma n cubed plus sigma n squared, that is 2 into n plus 1 by 2 the whole squared plus n into n plus 1 into 2n plus 1 divided by 6. This is your final answer. It can further be simplified by taking out common terms. Now, look at this, another one, 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on, n such terms. Now, you should observe that the difference of all these terms is just a constant. Okay? So, can't you write this as the 1 as 2 minus 1 by 1 into 2 plus 3 minus 2 divided by 2 into 3 plus 4 minus 3 by 3 into 4 and so on. So, separate them, isn't it? 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 and so on, and n such terms. So, what will the nth term be? Here it begins with 1 by 1, second is 1 by 2, it would be 1 by n minus 1 by n plus 1. Okay. So, this and this would cancel. What is your final answer? It is 1 minus 1 by n plus 1, that is n plus 1 minus 1, n divided by n plus 1 is the answer to the sequence. Okay. A similar way, I am just extending it a little further. Suppose I have 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 and so on. Okay, it is a similar question. So, again, what do you observe? That the common difference is 3. Let me introduce a 3 by multiplying and dividing by 3. 3 divided by 2 into 5 plus 3 divided by 5 into 8 plus 3 divided by 8 into 11 and so on. So, this is 1 by 3 into this 3 can be written as 5 minus 2 divided by 2 into 5 plus 8 minus 5 by 5 into 8 and so on. Okay. So, this is 1 by 3 into this is 1 by 2 minus 1 by 5 plus 1 by 5 minus 1 by 8 and so on. Okay. So, observe that these terms are going to cancel. In the last one, you are going to have 2 terms. So, let us determine which are those. Let us determine the nth term of this sequence 2, 5, 8 and so on, and 5, 8, 11. Anyway, the nth term here is going to cancel with this. Only the nth term of this sequence is going to remain as, what is it? 1 by What is the nth term? A plus n minus 1 into 3, which is 3n plus 2. 1 by 3n plus 2. What is your answer? 1 by 3 into 1 by 2 minus 1 by 3n plus 2, that is 1 by 3 into 3n plus 2 minus 2, which is 3n divided by 3n plus 2. This is your answer. Now another one. Find the sum to n terms of the sequence. 1 cube by 1 plus 1 cube plus 2 cube divided by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube divided by 1 plus 3 plus 5 and so on. So, let us write down the general term of a sequence like this. It is a n is 1 cube plus 2 cube plus 3 cube plus etc. The nth term would have an n cubed divided by 1 plus 3 plus 5 so on up to n terms. Okay, so what is the numerator? Isn't it n into n plus 1 by 2 the whole squared divided by denominator? It's the sum to n terms of an AP. What is the sum? It is n by 2 into 2a plus n minus 1 into d. So, this is n squared into n plus 1 the whole squared by 4. What's the denominator? It is 2 and minus 2 will cancel. So, n into 2n, which is just n squared, 1 by n squared. This is not all, this is only the nth term. So, the question is to find the sum to n terms, that is the sigma of this. Sigma of n plus 1 the whole squared by 4, 1 by 4 you take out, it is sigma n squared plus 2 into sigma n plus sigma of 1. So, this is 1 by 4 into sigma n squared is what? N into n plus 1 into 2n plus 1 by 6 plus 2 into sigma n is what? N into n plus 1 by 2 and sigma of 1 is n, because what are you doing? You are adding n, 1 n times. So, what is its sum? N times 1, that is n. Now, just one more. 5 plus 11 plus 19 plus 29 plus 41 plus so on, you are asked to find the sum of n such terms. Now, obviously, it does not look like any of the formulae that we have done before. So, what we will do is just find the general term. Okay. So, what is it that you observe here? The difference between consecutive terms, what is that? Here 6, here 8, here 10, here 12. So, what you observe is that the difference between consecutive terms, that forms an AP. Okay. So, in questions like this, what you do is call this as S. Okay. So, S is 5 plus 11 plus 19 plus 29 plus etc. Suppose the nth term I will call an. Now, this same S I will rewrite once again. So, S is also 5 plus 11 plus 19 plus etc. plus an, because I am just shifting one side. Okay. Now, subtract these two equations, the left hand side would be 0 is equal to subtract pairwise. Now, why I have taken it a little away is these are the pairs that have to be subtracted. So, the first term which has no pair, it is just 5. plus these pairwise if I subtract 11 minus 5, 6, this is 8, this is 10 and so on. Now, this an will be subtracted with this an minus 1 whatever that is, and this there is the 0 which is going to be subtracted with an. So, you would have minus an as the last term. Now, find out how many terms are there within this square brackets. Look at this. See, only the paired terms are subtracted. Now, in the given sum, don't you realize that there are n terms? Now, for subtraction, in the how many are pairwise subtracted? When you subtract, here in the first S, all except Y, 5 are paired and subtracted. So, there are n minus 1 terms that are subtracted. So, this bracket has n minus 1 terms. Okay. So, you take an to this side, you have an is 5 plus, look at this bracket here, isn't it an AP which has n minus 1 terms? So, what is the sum to n minus 1 terms of this AP? It is n minus 1 by 2 into 2a plus n minus 1 minus 1, that is n minus 2 into d. So, this is 5 plus n minus 1 by 2 into, this is 12 minus 4, this is 8 minus 2n. So, this is 5 plus n minus 1 by 2 into, take a 2 out, 4 minus n. So, this is 5 plus 4n minus n squared minus 4 plus 4n. So, this is 5 minus 4, 1 plus 8n minus n squared. Just let me see whether I have made a mistake here. Sorry, this is n minus 1 by 2 into 12 minus 4, 12 minus 4 is 8 and 2n. Sorry, this is 12 minus 4 is 8 and this is plus 2n. Yes. So, what did we have here? This is 5 plus n minus 1 by 2 into, take a 2 out, it is n plus 4. So, this is n squared plus 4 minus n, which is plus 3n, minus 4 plus 5 is 1. Yes. This is the answer. You know how I realized that I had made a mistake? In the previous one, when I substituted n is equal to 1, this is a general term, right? If I substitute n equal to 1, I should get the first term here. This seems right. 1 squared plus 3 plus 1 is 5. Second term is 2 squared, that is 4 plus 6 plus 1, 11. So, this is your nth term is actually correct. Now, you have got the nth term, your question is to find the sum to n terms. So, what is it? It is sigma of an. What is that? Sigma n squared plus 3 into sigma n plus sigma 1. This is n into n plus 1 into 2n plus 1 by 6 plus 3 into n plus 1 by 2 plus sigma of 1 is n. Again, this can be simplified by taking out common factors. So, I hope this chapter is clear now. I'll come back with some MCQs on this chapter at a later date.